Good evening, my dear J25 and 2026 warriors in the Roar series. Welcome all the lions. It's time to go ahead and we are going to start off with the kinematics part. And today we are going to do motion in one dimension. There is a separate topic called motion in two dimension or motion in a plane, which will incorporate projectile motion, projectile on an incline, and all those stuff. Today, everything about motion in a straight line. Some books might use this name instead of motion in 1D, so do not get confused, right? So right from the basics to the top-notch level with all the level of problems, with handwritten notes, with the concepts, with the questions and the PYQs in this class with your Captain Shreyas. Quickly smash that like button right now, mark your attendance and subscribe to the Vedantu J English channel right away right now, guys. Nice to see all of you back. Hi Divakar, Mesroor, Lucifer. Hello Adiksha, nice to see all of you. Good evening. Hello Neela. Can NEET aspirants also watch it? Yes, definitely you can watch it, but the level will be slightly on the higher side. Bear that in mind. Okay, cool. So, hi, Vishal. Nice to see all of you back over here. Cool. Ready to begin with the class? Full of josh, full of energy. Smash the like button already. Have you shared the link of this particular video with your friends, with your batchmates? If you have not done that yet, do that right away, right now. Okay, because it is not just for you that you're going to watch the session. You have to also share this particular channel link with all your friends, because this is a channel which was created for you, because a lot of channels are there in Hindi, not many channels in English. And those of you who have also seen other channels, though they have tried, but they have not succeeded yet. So because you need to maintain consistency, you need to deliver quality content, you need to have right mindset, you need to understand what the audience needs. So guys, we are here for a long time. Make sure that you are talking about the Vedantu J English channel, right? Cool. This is your Captain Shreyas signing off. No, I'm not. I'm here only. Yeah. Hairstyle is nice. Thank you so much. DNA student is also here. Yes, you can also watch it. Cool. So let's begin. Let's begin. See, when we say about kinematics, understand it is actually a fancy word for motion, and understanding that motion. So when I say anything is moving and everything around you either stays at rest or is in motion, and we are basically studying what will happen to the motion after some time. So basically, kinematics is just a fancy way of saying I am studying this motion, the study of this motion. Like, where is it? When will it come? How much will it move? How much will it move? Or how much time will it take? All those kind of things we study in basically kinematics. And you should also realize that everything which is around you, which you say that, oh, the tree is at rest, okay, that car is moving at so and so speed, these are all relative terms. These are all dependent on the observer. There is nothing like absolute motion or absolute rest, because you might say the tree, sir, is stationary, but think about it for a moment. If you start to move, then the tree is actually moving in the other direction. You'll be like, no, sir, what are you saying? You are moving, the tree is at rest. That is also wrong to say, because if you think about it, the earth is moving, and if earth is moving, obviously the tree is also moving. Then like maybe the sun is at rest. No, even the sun is moving. The sun is moving around the center of the galaxy. The center of the galaxy is moving around something else. So there is nothing like you can pinpoint, oh, this is the point which is at rest in this universe. Everything is relative to something. Everything is, relative. Nothing in this universe is absolute in terms of motion. Keep that in mind. So the observer decides whether something is at rest or something is at motion. Tell me, how many times has this happened with you? You are probably sleeping in a bus or sleeping in a car, and there is a neighboring bus or a truck or whatever, and then slowly you open your eyes and you see, and then you're like, okay, finally the bus has moved. And then you realize, oh, wait a minute, the bus is not moving. That truck was taking a reverse. I felt like I was moving front. How many of you have experienced this? First hand experience of relative motion, right? You're seeing, suddenly you are watching some TV, checking your phone, sleeping. You look aside and you feel that you are moving, and then you realize, no, I was not moving. That neighboring person, that neighboring truck, bus, car, whatever was moving, or the train was moving, and then you realize, oh, we were at rest. So whenever an observer makes a judgment, understand they are making it with respect to something. You always, compare, oh, the tree is at rest, with respect to the tree, the bus is moving. Oh, so that's why you say the bus is moving. Understand that. Okay, so you always compare it with the surroundings, the mountains, the buildings, the trees, the road, etc. So many of you experience this, Lucifer, Divakar, and so many of you. Yep. Uh, Definitely, SHKT Charan, why not? You can get anything. I mean, it all depends on your hard work, perseverance, consistency, and so many other things. Good evening. Name. Yep. So now, having said this, the main important thing over here is something called as the frame of reference. This is basically the point of view, POV, which is also called. It is completely dependent on the observer. It is completely dependent on the observer, and the point of view basically has, the coordinate axis. You have the X, Y, Z coordinate axis with the origin, and you also have a stopwatch or a time, measuring instrument, because you have to also measure time over there. Okay, how much time has elapsed? So everybody might measure different time. Or for me, I have started the stopwatch now. It has, taken 2 seconds. Somebody else might say, no, I started the watch before only, and then I stopped the watch here only. So, every person might start and stop the watches at different time. So you also put time in the, perspective for point of view or for frame of reference. So this is where your observer is. Our observer is none other than Pandu. So our observer is Pandu. So this is Pandu, and Pandu is making those observations. Pandu is making those observations. Great. Now, first things first, what is position? Now, since we are talking about motion in 1D, so I will stick to one-dimensional motion. Later on in 2 dimension, we'll go to that. So you can have any axis, either x-axis or y-axis, doesn't matter. So let's say this is the origin, and let's say our Pandu is over here. Let's say our Pandu is over here at this particular moment on this plane, on this line, on this x-axis. So whatever is the coordinate happens to be the position of that particular particle, or the person, or the body, or the car, or the vehicle. We treat everything like point objects. So you will see that it's an unsaid rule. What is an unsaid rule? What is the unsaid rule? The unsaid rule of this chapter is, unsaid rule of this particular chapter is, all the objects or bodies are treated are treated are treated like points, are treated like points. Like you will see, a car overtakes some signal, a car stops after some time. Many of you will be wondering, sir, which part of the car are you talking about? Are you talking about the front part or the back part? So here we treat the car like a point, or you just take a center of the car and then you are referring to the car as a whole. So understand, we treat bodies like points over here. Okay, I hope this is clear. No, Shanmuga, you're not late. We have just started with the class. So join in and get others too. Yes, we have just started. Now, the next important thing that you need to also really understand is that position of any body. So position of a particle, because we are referring to bodies as particles. Position of particles is given in terms of the coordinate, in terms of the coordinates of that location. Keep that in mind. Okay, so it's just nothing but the coordinates of that location. If it is moving in the y-axis, it will have y coordinates. If it is going in the z-axis, it will have z coordinates. If it is in the x, it will have x coordinates. Because we are talking about motion in a straight line, it will only depend on one axis. If it is going in a plane or in flying mode, then it might have x, y, z all the three coordinates it might be having. Okay. Now comes the main thing, which is slowly we are going to go towards distance, displacement, velocity, kinematics, motion in gravity, motion under acceleration, straight line, okay, horizontal direction, non-uniform motion, graphs, all these things we are going to study today. Now, distance and displacement, very straightforward, guys. See, if you start at a point, so this is your start, and you've reached here, this is your final destination. This is your destination. This is your destination or current location or your current location or your current location. You started from here, uh, or basically this was your initial location. This is your final destination. You started from here and you reached here. Then if I join the initial and the final point, if I join the initial and the final point with an arrow mark pointed towards the final location, that is referred to as displacement. That is referred to as displacement. It's a ray which starts from initial, ends at the destination or the current location. That is basically your displacement. Usually the symbol for displacement is S. It's a vector quantity. This displacement, understand, it is a vector quantity. Whereas distance, understand, it is basically the actual path which I have taken. See, a Pandu might have actually gone like this. He might have actually gone like this. So the actual path which Pandu has taken is basically the distance. So distance is usually used, is represented using the symbol d. And remember that distance is actually a scalar quantity. Is actually a scalar quantity. So imagine me over here. I started and I went here, I went there, I went here, I came back to my original location. Tell me in this process, is there displacement or is there distance? Put it up in the chat box. I started from here, I went here, I went here, I went there, I came here, and I went there, and I again came back to my original location. Tell me, do I have distance or do I have some distance traveled or do I have some displacement traveled? Obviously, that there is distance because I have traveled a path. So definitely there is some distance, but my current location and final location is the same. So there is no displacement at all. So there is no displacement at all. Satyam, my branch was mechanical, right? Concentrate now. Everybody with me? Yes. So basically, yeah, my displacement will be zero. Distance traveled will be there. In fact, you will see in most of the cases, if I go like this, and if I join a line like this from the initial to the final point, the distance will be more than the displacement unless I traveled only in a straight line, then the distance and the displacement both will be same. So usually you will see that the magnitude of the displacement or just the displacement's value will be less than or equal to the distance traveled, will be less than or equal to the distance traveled, because always the distance, which is the length of the path, might be more than the straight line joining the initial and the final locations. Also in some cases, it might be possible that if you, let's say, start and come back to the same point, in such cases you will see that the distance traveled is not zero, whereas the displacement traveled will be zero if you come back to the same point. I hope this is absolutely very, very clear in everybody's head. Cool. Shall we go ahead? Right? Shall we go ahead, my dear warriors? Very nice. So distance is the total length of the path of the particle's motion, whereas the displacement is the straight line distance which goes from the initial to the final location. It has a direction, it is a vector quantity because it has both direction and magnitude, whereas distance is a scalar quantity. Very, very straightforward. Now imagine this. Okay, let's talk about distance and displacement even further. Say, I give you an example like this. the hands of a clock. The hands of a clock. Tell me, if you take the tip of the, tell me, if you take the tip of the hand of the clock, okay, any hand of the clock, let's say you wait for half a revolution. Let's say you are talking about the second hand. So after 30 seconds, if you talk about the minute hand, then after 30 minutes, you wait for half a revolution to happen. So basically that particular hand will come over here. So that tip would have now come over here. That tip would have now come over here. If I ask you, what is the distance traveled by the tip versus what is the displacement of the tip? What is the distance traveled by the tip, whereas what is the displacement of that particular tip? What will your answer be, assuming the radius of the hand of the clock is basically r? Radius of the hand of the clock is basically r. Well, simple guys. The displacement of the tip, you can see from here to here, it's just the diameter. It is basically just the diameter, which is nothing but 2 times of r. Whereas if you ask me the distance traveled, well, it is half the circumference. So it is whatever the circumference will be there divided by 2. Hence it will just be pi r instead of 2 pi r. That will be the answer. That will be the answer. Whereas for one complete revolution, imagine if it was one complete revolution, let's say you wait for 1 hour for the minute hand, or you wait for 60 seconds for the second hand, then what will you see? My dear warriors? Think about it. What will happen? The answers will change. This distance traveled for one complete rotation will be the circumference, and hence the answer will be 2 pi r. Whereas if you talk about the displacement, then you are coming back to the same point. Hence the answer will be a big fat 0 for one revolution. This was for one revolution. This was for half a revolution. Okay, so I think these problems are making the concepts of distance and displacement even more clear. Now, one more thing which you need to learn is displacement in terms of the position vector. Displacement in terms of the position vector. Meaning, if I know initial and the final position, can I write displacement in terms of that? The answer is yes. I'll tell you how. Say for example, this was my initial position, and let's say P2 is my final position. This is my final position. Then a line joining the initial and the final position, will be the displacement. So realize this, displacement is actually the change of position, I was here, now I am here, this is the change. So strictly speaking, displacement is the final coordinate of x minus the initial coordinate of x. Basically, I can also write displacement is delta x. Delta means change. So final minus initial. If you were on this number line, and let's say earlier you are at x is equal to -2, later on you are at x is equal to 5. If somebody asks you what is the displacement of this person from here to here, well, this was initially, this is right now. When I say t is equal to 0, it means initial. When I say t is equal to t, that means it is final or current position. So from here to here, I have displaced some amount. So if that displacement is asked, it is final minus initial. Final is 5 coordinate, initial is -2, hence the answer is 7. So the displacement is 7 meters. So the displacement is 7 meters. You take the final coordinate, you take the initial coordinate, subtract it. It kind of makes sense also because the origin will be here. This is 2, this is 5. 2 plus 5 is 7. So makes sense. So this is how you measure the displacement in terms of the coordinate or the positions. In terms of the coordinate or in terms of positions. It's one and the same thing. Till this point, everything clear, my dear warriors? Give me a thumbs up, then we'll go ahead. Yes, we are starting with the basics. Slowly, we are going to scale it up. Right? Okay. Now that you have understood it till here, let's move to the next part, which is speed and velocity. So once Champa said that, to Pandu that she needs some time to think about something. I don't know what is that. And we also need to maintain some distance. So our Pandu actually thought that maybe Champa is calculating velocity because Pandu is a physics student, right? He has learned under your captain Shreyas Sir. So, guys, when you know how far you have traveled, what is the distance it is, this particle has traveled, in how much time, you can calculate how quickly it has reached there, and that is your speed. But instead of distance, I use the word displacement. Well, then that displacement which has occurred in how much time? So, how quick is that displacement gives me velocity. So it's exactly like distance versus displacement. Same difference is there between speed and velocity. Just like distance was scalar, speed is also scalar. Just like displacement was vector, velocity is also vector. That's all. So let's learn about that. Let's learn about that. Let me just create duplicates over here. Yep. So this is the path which was taken by Champa or Pandu, right? And this was the straight line distance from here to here. So that was the displacement. This was distance. So guys, speed is nothing but how quickly you travel that distance. So it is nothing but the distance which you have traveled upon the time which you have taken. Distance which you have traveled upon the time which you have taken. Usually the symbol for speed is V. Distance traveled, usually you will use D. Time taken, let's say you can use the symbol T. So speed is distance by time, or distance is speed into time, or time is distance by speed. This is something which you have learned a long time back also. But mind it, this is not any speed, this is actually average speed that we are talking about. Okay, because this is a long time interval. You have traveled some, city, from one city to another city, or you have gone from your house to school, or you have gone from the shop to some workplace. So this is a long path. So, or you have taken some decent amount of time. So that is why this is average speed. We'll come to instantaneous in a bit, but for now, this is average. Same way, I can also write average velocity, average velocity as the displacement which has occurred upon basically the time which you have taken, upon the time which you have taken. So the symbol for velocity is v bar. It's a vector quantity and it is average. So I will put avg over here. Displacement is basically s bar. Time taken, you can put capital T, or some books also use delta T. It's one and the same thing. It's one and the same thing. So you can also use delta T. Okay, capital T or delta T, it's one and the same thing. Delta T means time interval. T means time taken. It's the same thing, guys. Don't get confused. Okay. So distance upon time is average speed. This is a definitely scalar quantity, whereas this one over here is definitely a vector quantity. It's a vector quantity. If you want to rewrite in a much better form, you can also write average velocity. Remember, displacement was delta x. So it was delta x divided by time. You can also write it as delta t. So can I cancel this, guys? Delta and delta. So I'll get it as x by time. Yes or no? Can I cancel this delta and delta? Pakka? Come on. But you could calculate only speed maybe. Okay, come on. No, right? Thank God. You can't do such things. Okay. What is delta? Delta is change of something. This is change of time. Okay. Or else you will start doing random things. Sine by tan. You will say, sir, this sine theta by tan theta, sir, n cancel. Theta also cancel. Sir, it is psi by ta. So you will do all sort of stupid things. So this is not possible, guys. This is just an operator. So you cannot cancel it like that. Okay. Never ever do that. Yep. It is not possible. Chumma, I was playing around with you. My God, don't take it seriously, guys. Obviously, it is not possible. Okay, cool. Let's go ahead. Let's go ahead. Very good. So, this is something which we need to block. Average velocity definition. Also, average speed definition. I think you can block it here only. Distance by time. But then you also have something called as instantaneous velocity. Instantaneous velocity. Let's say you take a very small time interval. Take a small time interval. When I say you are taking a very small time interval, means delta t tends to 0, but delta t not equals to 0. The time interval is very small, very close to 0. It is infinitely small. You cannot assign a value or a number to it, like 0.1, 0.01. No, it is even smaller than that. But it is not 0 because you have to give it some time to move so that you can calculate speed. So to calculate speed, you need both. How much have you moved and how much time you have taken. If you have not taken only any time, then how much will you move? You can't move within no time. You have to move in some time at least. Some time will always be taken. This entire thing, what is it called? It is just called as dt, right? I hope you remember this from derivatives, basic maths. This is just called as dt, or the smallest time interval possible. So take a small time interval. So in that dt time, in that dt time or interval, the particle displaces how much? Particle displaces how much? ds, a very, very small displacement, which is basically ds. You can call it ds, or you can also call it dx, one and the same thing. A very, very small displacement, ds or dx. So then my instantaneous velocity, instantaneous instantaneous velocity instantaneous velocity will be v bar is equal to that small displacement which has occurred, which is basically dx upon basically dt. So it is just dx by dt, or you can also put ds by dt, one and the same thing. Very small displacement upon very small time, that will give you your instantaneous velocity. So whenever the word used is just velocity, realize that we are referring to instantaneous only. If the word used is average, then they actually mean average. So when they say the velocity of the bus is 50 kilometers per hour, it means the velocity at that moment for that bus is 50 kilometers per hour. They are not referring to average, they are referring to at that moment what is the velocity. Keep that in mind. Okay, so that is the meaning of the term instantaneous velocity. Is that clear, my dear warriors? Dx by dt. Again, you cannot cancel d and d because that is derivative of x with respect to time. Okay, or differentiation of x with respect to time, or rate of change of x with respect to time. It is all meaning the same, instantaneous velocity. Okay, so when you have the term like average, it is delta. When you have the term like instantaneous, you have dx and dt. Okay. Lakshmi, I'm not sure why it was not uploaded. I'll just look into it, Chalok. Okay, I'll just look into it. Okay, don't worry, it will get uploaded. Yep, very soon. Very soon. Okay. Now, moving ahead, tell me one thing. If you compare speed versus velocity, speed versus velocity, who will be more generally? Who will be more generally? Think about it and tell me. Because speed is measured by calculating distance, whereas velocity is measured by calculating displacement. So think about it. Obviously, distance is always more than the displacement unless you are moving in a straight line path. Hence, speed will be more than or equal to velocity. Always. Also think and tell me, out of speed and velocity, which of the following are possible? Speed is 0. Speed is not 0. Then you have velocity is 0, velocity is not 0. Which of the following do you think cases are possible and not possible? Just think about it. Is this first case possible or not possible? Just think about it. Is this first case possible? Speed is also 0, velocity is also 0. I think it is possible. A particle is at rest. Definitely, it is possible. This is possible. Imagine something is at complete rest. So it is neither moving, no speed, no velocity also. Is this possible? There is no speed, but there is velocity. How is this possible, guys? Think about it. The particle has no distance traveled, but there is velocity. That means there is displacement. Can something have displacement but no distance? I think this is not possible. I think this is not possible. So you can't have displacement without distance traveled, without distance being traveled. This is not possible. What about the next one? There is distance but no displacement, or there is speed but no velocity. I think this is possible. Imagine you start from a point and you come back to the same point. So in this case, displacement is 0, but distance traveled is not 0. So because there is distance, there is speed. Because there is no displacement, there is no velocity. So I think this is possible. What about this one? Both of them are not 0. Yes, definitely possible. Like in this case, there is some distance, there is some displacement, hence there is some speed, there is some velocity. So this particular case was not possible. Rest other cases were possible. Yeah. Alpha, you don't need to watch any other previous classes. Only thing you might need for this particular chapter is basic maths. So if you have not yet done basic maths, I would suggest please study that basic maths part, which is derivatives and integration. Okay, apart from that, you don't need to do anything else. Yep. Great. So that was velocity and displacement and velocity and speed, and how they are related to distance and displacement. Okay. So let's do some questions coming up on your screen. There is a clock which has minute hand 4 centimeters long. Find the average velocity of the tip of the minute hand between 6 a.m. and 6:30 a.m. between 6 a.m. and 6:30 p.m. Interesting question, guys. Let's think about it. Initially, when it is 6 a.m., 6 a.m. means the minute hand will be over here. This is exactly at 6 a.m. When we talk about 6:30 a.m. or 6:30 p.m., realize the hand would be over here. So this is at 6:30 a.m. you take, or p.m. you take, that minute hand will be down. So first of all, in either case, you have to find velocity of that tip of the hand. Okay. So think and tell me, from here to here, what is the displacement? It was on the top, it went down. So what is the displacement in this case? Obviously the displacement is nothing but the diameter, which is 2 times a radius, which is 2 times of 4, which is nothing but 8 centimeter. So displacement is 100% 8 centimeters. That is not a problem. But the question is, for 6 a.m. to 6:30 a.m., 6 a.m. to 6:30 p.m. So both answers will be, I feel, different. So for the A part, when I calculate the average velocity, displacement by time, displacement is 8, but time won't be. What is time? Time won't be like 6:30 or anything. You can't put 6:30 like that. You have to think in terms of minutes or seconds. Convert it. From 6 a.m. to 6:30, how much time has elapsed? 30 minutes. So you're going to put 30 minutes, but generally you do not leave the answer in minutes. So what you do, you convert it into seconds. So 30 into 60. So that is what the average speed will be in centimeters per second. That is what the average speed will be in centimeters per second. Is that right, everybody? Correct. Similarly, for the B part, when I calculate the average velocity to be displacement by time, displacement is still 8 meters. But the time, guys, it's not so simple. Be careful. From 6 to 6:30, it's 12 and a half hours. It's basically 12 and a half hours. So you need to convert it into basically seconds. So 12 hours will have 60 minutes each. So 12 into 60 minutes into 60 plus that extra 30 minutes that you get, and each minute will have 60 seconds. So this is what the answer will be in centimeters per second. In centimeters per second. Okay, I hope you understood. The calculation part is the secondary part. Main thing is to get these numbers right. So this is 12 hours, 12 hours. Each hour has 60 minutes, each minute has 60 seconds. That extra half an hour has 30 minutes. Each minute in that has 60 seconds. So that's why those numbers have come over there. Clear? Shall we go ahead, my dear warriors? Understood till here how these numbers have come? Excellent. Moving on to the next one coming up on your screen. There is a person who is traveling on a straight line moving with uniform velocity v1 for some time and with uniform velocity v2 for the next equal time. The average velocity v is given by what? Okay, think about it. So for some time v1, for some time v2. So what do we need to do, guys? For some time is v1. Okay, for some time from here to here it is v1, and then for the next same time with some new speed, maybe the speed is more, who knows, then you will travel more distance. Okay, but the time is the same. The time is the same. Distance won't be the same. In fact, this distance, what is the relation between distance, speed and time? Speed is distance by time. Distance is speed multiplied by time. So this distance will be v1 into t. If you talk about this distance, that will be that speed into time. So the distances will be different because the speeds are different. The question says, what is the average velocity? What is the average velocity? So in order to find the average velocity, we will take the total distance. We will take the total distance and we'll divide it by total time. We'll divide it by total time. What is the total distance? Well, that is d1 plus d2. What is the total time? That is t plus t. What is d1? It is v1t. What is d2? That is v2t. What is this over here? 2t. T cancels, so I will get v1 plus v2 whole thing divided by 2. v1 plus v2 whole thing divided by 2. That is option number A. That is option number A. Very good, Adiksha. Excelente. Hirtami, Nagmani, yes. Muruhari, it is not C. Yes, Mesu. Answer is A. Correcto. Proud of all of you. Moving on to the second variation of the problem, where you have a person traveling again in a straight line. For some distance, he travels with speed v1, and for the next equal distance, speed v2. So here, time is not same. Here, distance is same. So let's say this is distance x, you travel with speed v1. The same distance x, you travel with speed v2. Because the speeds are different, times will be different. So this time will be distance by speed. So x by v1. This time will be again distance by speed, which is x by v2. Time is distance by speed because speed is distance by time. So time will be distance by speed, correct? So now again we have to find the average velocity. So in order to find the average velocity, what will we do? Again use this total distance upon total time. Upon total time. Let's see what do we get. Total distance is x plus x. X plus x is the total distance. Total time is t1 plus t2. This and this times are different. X plus x is 2x. T1 is nothing but x by v1. T2 is nothing but x by v2. X cancels off, so I'll get 2 divided by 1 by v1 plus 1 by v2. So I don't see any answer like that as of now, but I think I have to rearrange it properly. How? Observe this. This was your average velocity. This was your average velocity. Take this 1 by v1 plus 1 by v2 on the right hand side, sorry, on the left hand side. So it will become v into 1 by v1 plus 1 by v2 is equal to 2. Shift that v below. So it will become 1 by v1 plus 1 by v2 is equal to 2 divided by v. So I can see this is exactly matching with option number C. Hence, this is the correct answer. Hence, this is the correct answer. In this case, yes, guys, the correct answer was option number C. Correcto. Perfect. Now you guys got it. Awesome. Shall we move ahead? So both were different questions, both had different criterias. One had same time, one had same distance. Okay, so accordingly, you will change your solutioning. Moving on to the next concept, and that is acceleration. Slowly, we are building on the concepts of velocity, displacement, speed, all these things, learning about acceleration. Then we'll go to kinematics, motion under gravity, and all those things. Now, average acceleration and instantaneous acceleration. See, acceleration means how quickly are you changing your speed? So let's say you're driving a car, your car speed is 40 kilometers per hour. You want to overtake. From 40, you go to 60 in 2 seconds. Another car is there very slow. From 40 to 60, it increases the speed in 10 seconds. You press the accelerator, aram say it will increase the speed, after 10 seconds. That second vehicle has very low acceleration. That first car had very good horsepower, maybe very good torque, very good engine. So within 2 seconds from 40 to 60, zoop, it went off. So it has better acceleration. So acceleration is nothing but your how quickly your velocity changes. So of change rate of change of your velocity. Rate of change of velocity, not speed. Lot of students make a mistake here. They say rate of change of speed is acceleration. No, rate of change of speed is not acceleration. Rate of change of velocity is acceleration. Adiksha, aram se means slowly, chill mode, full on chill mode only. That is the meaning of aram se. Okay, cool, right. Moving on, moving on. So, how do I symbolize? How do I mathematically write average acceleration? And then we'll go to instantaneous. So average acceleration by definition is how much is the change of the velocity upon the time. So change means final minus initial, whole thing upon time taken. You can write capital T or you can also put delta T. So you can also write the average acceleration like this. Final minus initial of velocity is delta V. Delta means change, final minus initial, and you can put delta T. Obviously, you can't cancel these deltas. So that is what acceleration is defined as. Now keep this in mind that acceleration is obviously a vector quantity. It is a vector quantity, and the units usually which are used are meters per second square or centimeters per second square. Okay, it's a vector quantity because you will see the direction matters. The direction will decide whether it is increasing or decreasing, the velocities. In fact, I can tell you one simple thing over here. Let me just create a duplicate. Yes. Imagine there was a Pandu. Imagine there was a Pandu and his velocity was maybe 3 meters per second like this. This Pandu, his velocity 3 meters per second like this. Same thing over here. His velocity 3 meters per second like this. This Pandu, his velocity 3 meters per second like this. If by chance I tell you, in the first case, the acceleration is here, maybe something like 2 meters per second square, example, or here 2 meters per second square. In both these cases, acceleration and velocity, are in the same direction. So what happens next is the value of the speed increases. So that 3 meters per second in the next 1 second will become 5. In the next second, it will become 7. So it will keep on increasing the speed by 2 meters per second every second. So here in both the cases, the speed will increase. So what will happen in both these cases? In both these cases, when acceleration is parallel to the velocity, the speed increases. What happens? The speed will increase. Keep that in mind. Whereas in this scenario, imagine the acceleration is opposite, let's say, to the velocity. Here, the velocity is here and the acceleration is this side, 2 meters per second square. Realize that Because the acceleration is opposite to the velocity, this velocity will keep reducing in magnitude. So this 3 in the next second will become 1. Yep. So you will see in such scenarios where acceleration is anti-parallel to the velocity, the speed reduces. The speed will be reducing. Very, very important point. The reason why I want to tell you about this is because I have seen so many students saying this, that you know what, sir, when acceleration is positive, speed increases, and when acceleration is negative, speed decreases. I don't blame you. Probably you are taught like that only in many of your coaching or school. This is wrong to say that when acceleration is positive, speed increases, and when acceleration is negative, speed decreases. That is wrong. In fact, check this out. If I choose my right hand side as the positive direction, this is positive x-axis, that is negative x-axis. Think over here, think over here, velocity and acceleration both are positive. Here, velocity and acceleration both are opposite to the sign convention, so it is both negative. Basically, both of them have the same sign. Understand that. Both of them have the same sign. So in this case, my acceleration was positive. In this case, the acceleration is negative. Do you see, in spite of the acceleration being negative, the speed is increasing? In spite of the acceleration being negative, still the speed is increasing. Why? Because it has the same sign as that of the velocity. Velocity is also negative, acceleration is also negative. Both are negative, speed increases. Both are positive, speed increases. Here, if you notice, acceleration is, let's say, positive, but velocity is negative. Here, velocity is positive, acceleration is negative. So the signs are opposite, and that's when the speed reduces. So the true way of checking speed increasing or decreasing is not by the sign of acceleration. That is the most important thing. Okay, so speed increasing or decreasing depends not on the sign of acceleration but on the relative sign. So acceleration and velocity both are the same sign. Velocity and acceleration are basically of the same sign, then it is increasing, whereas acceleration and velocity are of different, or I would say opposite signs, then it is decreasing in nature. Okay, then it is decreasing in nature. Very, very important. And what if there is a particular scenario where, if acceleration is only 0, there is no sign for 0. 0 is neither a positive number nor a negative number. If such is the scenario, then what can you comment about the velocity, my dear warriors? Then what can you comment about the velocity? If acceleration is only 0, what can you comment about velocity? Think about it. Well, if the acceleration is 0, that means velocity is not changing. That means velocity is 0, wrong. Velocity is just a constant. Velocity is just a constant. It is basically not accelerating. It is not accelerating. So such a motion is called as uniform motion, uniform velocity, uniform velocity. The particle is moving with a uniform velocity. That means constant velocity. 2 meters per second, 2 meters per second, 2 meters per second, 2 meters per second. Constant velocity, straight direction it is moving. That is uniform velocity or zero acceleration. Okay, I hope this is clear. Think about it, here Tami. Acceleration is 0, no change. There is no change in velocity. When, imagine, Pandu meets Champa after a long time, and Pandu says to Champa, Champa, you have not changed at all. Champa, you have not changed at all. That means what? Champa has remained constant. Understanding it? So acceleration 0 means no change in velocity. Yes, that is what it is. Very good. Clearo, shall we move ahead? Shall we move ahead to the next concept? Right? Okay, great, great, great. So basically, Oh, we had to talk about instantaneous also. Just 1 second. We did not talk about instantaneous. I'll talk about that. So you now understood the sign convention and what is increasing and decreasing speed. So say for example, my dear warriors, we want to find out instantaneous. Now, whatever we spoke was in general on an average, what is the acceleration? We want to find out instantaneous. Instantaneous means in a small time, in a small time interval, that means dt, the velocity changes. How much does it change by? Changes by dv. Say for example, there was a particle here, it had some velocity v. After moving some small distance ahead, it got a new velocity, and that new velocity was v plus dv. So you can see there is a change, and this change has happened in time dt. So initial time was, let's say, t. This time is basically at t plus dt. The interval is dt, the change is dv. So then I will write down the instantaneous acceleration. This is instantaneous acceleration. So this is instantaneous acceleration. That will be just dv divided by dt, nothing more. Instead of delta, there will be d. That's all. That's the major difference if you compare it with the previous formula. Instead of delta v by delta t, now you are going to write it as derivative of velocity with time, differentiation of velocity with time, rate of change of velocity with time, dv by dt. One and the same thing. Okay, it's at that moment, at that instant. That is what it is. Is this point clear, my dear warriors? Okay. All right. Great. Great. Cool. Now, I have put it up in the summary part here, just in case if you want to read more about it, average acceleration and instantaneous acceleration. You will also see that actually dv by dt is also the second derivative of position, because velocity was a derivative of displacement. So if you want, you can also write it as d by dt. Velocity itself was displacement's derivative with respect to time. So this is nothing but the second derivative. So this is second derivative of displacement with respect to time. That is also understood. Derivative of a derivative or second derivative. Cool? Okay. Now let's take up examples related to acceleration before we move ahead. Imagine there was a car which is moving at 5 meters per second and reduces its speed to 2 meters per second in in 0.06 seconds. In 0.06 seconds. Question is, how much is the acceleration? How much is the acceleration? Assuming this direction, I am taking it as positive by sign convention. So what will I do? If I want to find the acceleration, all I need is how much is the change in the velocity divided by the time which has been taken. Change is always final minus initial. What is the final? 2. What is the initial? 5. Subtract them. How much time? 0.06, which is nothing but 3 with negative sign divided by 0.06. Well, you can write it as minus 3 by 6. This is 10 to the power minus 2. So you can write it 10 to the power 2 on the top. 10 to the power 2 on the top, right? So 3 by 6, what is it? Half. So it is half. So it is nothing but minus 1 by 2. 10 square is nothing but 100. So it is nothing but minus 50 meters per second square. That is the answer. This negative sign is merely telling that whichever direction you took positive, the acceleration vector is in exact opposite direction. So the acceleration of the car is in this way. So if I had to write down the acceleration, I will put it as minus 50 I cap meters per second square. Minus 50 I cap meters per second square. I cap, remember that vector notation. Yep, exactly. Make sense? Okay. Now let's modify the question a little bit and see whether you get the answer or not. Say for example, car was traveling in this particular direction with a speed of 20 meters per second and immediately drifts and takes a U-turn and travels with the same speed of 20 meters per second. All this in, let's say, 5 seconds. Question is, what is the acceleration in this motion? What is the acceleration in this particular motion? And let's assume again this side as positive. Whatever happens on this side is positive. Let's go by the proper sign convention so that we get proper answers. So, according to definition, it is final minus initial divided by the time interval. What is the final velocity? Well, it is 20 and it is in the same direction as the positive direction. So, I'll put 20 plus minus this minus same over here. Initial velocity is 20, but in the left hand side, so I am going to put this as minus 20. Why minus 20? Because of the direction of this arrow mark. It is left side. Assumed direction is right side. That is the reason. A lot of you are saying the answer as 0, which is wrong. Divided by 5. So it is 20 plus 20, which is 40 divided by 5, which is 8 meters per second square. Since the answer is positive, it means the car's actual acceleration is in this direction. So it is 8 I cap meters per second square towards the right hand side. That is what the positive sign suggests. Okay, so the answer is not 0. Understood why it is not 0? Clear? Because this minus will not cancel because the signs are opposite. 20 first time is here, second time is here. So directions are opposite, so the signs will be different. So instead of subtracting, they will add now. Keep that in mind. So that is how you find out acceleration in one dimension. So everybody clear with velocity, displacement, acceleration, be it average or instantaneous? Yes, we'll be coming to derivatives questions in a bit, not now. Now comes the main part of the chapter where we'll use these parameters to find out different things, which is called as equations of motion. So what is this equations of motion? These equations of motions basically tells me where is it going to be, how much time will it take, how much will it travel, when will the velocity be this much, what will be the speed then, what might be the speed then. All these things will be obtained using these equations. But there is a small catch in this, and the catch in this is that these equations are only and only valid when the acceleration is constant. So just to show you how these equations come into play, starting off with only and only if acceleration is constant, everything works. Otherwise, nothing works. Okay. Starting off with the definition of the acceleration. What is the definition of the acceleration? It is nothing but dv by dt. It is nothing but dv by dt. Okay, great. So let's rearrange the terms. So it will nothing but be acceleration is a times of dt. Accelerate. Change in velocity is acceleration times dt. I've just taken dt over here. Now I will put integral symbol on both sides, a dt. I will just put integration here and I will put integration here. Now once I put integration, I can do definite or indefinite. I will go by the definite way. So when the time is 0, see whatever you integrated with respect to, only that variable's limits will come. I'm not going to put the limits of acceleration. I'm integrating it with respect to time. So what is the time initially? 0. What is the variable I'm integrating it with? Velocity on the left hand side. So velocity's limits will come. What is the initial velocity? It is u. Usually the initial velocity is assumed to be u. Final velocity is assumed to be finally v. Yep. So this is how it works. You start with some initial velocity, you move some displacement, and after some time you have some final velocity. Here you just started. Here is the current time. You have taken time t to reach to the velocity v, and you had some acceleration. Is this understood? So always whenever you put limits, remember similar conditions should match. When time was 0, what is the velocity? Exactly that velocity should come here. Later on, when the time taken is t, that time what is the velocity? V. You cannot interchange these variables. You don't say, oh, I'll put v here, u here. No, you should look on that side also. What is the time? T. Oh, after time t, my velocity is v. Oh, initially my time was 0. that time my velocity will be u. That's how you do it. Okay. So what is the integration of dv? Integration of dx is nothing but x. So dv's integration is just v only, but I have to put limits over here, which is u and v. A is a constant, so bring it outside. Dt's integration is just t only. So I'm just going to put 0 over here and t over here. Just doing the math over here. Okay, continuing the things. Put v first, then you put u and subtract. Then put t first and then put 0. So a and then t minus 0. So take that u on the other side. What will you get? V is equal to u plus at. This is your first kinematic equation. What is this called? This is your first kinematic equation. Till this point, everybody clear? This is the actual derivation of the equation of kinematics. Okay? Anything else is just some random derivation which goes in the air. This is a true derivation of kinematic equations using derivatives and integration. But we won't stop here. We will proceed ahead. We will think, okay, wait a minute. Can I do something with displacement? Answer is yes. Velocity is nothing but dx by dt is nothing but dx by dt. So this is u plus at. Okay, I have replaced velocity with dx by dt. Remember, I just told you instantaneous velocity right over here. Where did it go? Where did it go? Yes, see over here, velocity is dx by dt, rate of change of position. Cool. So I can now continue with this over here. I will just take that dt term on the other side. So dx will be nothing but u dt plus a times t dt. I think the next step should be integration. The next step should be integration. So I'll put integration symbol over there. So integration of dx will be u is a constant. So I'll put it outside. Integration of dt plus, remember a was a constant. So it will be outside the integration. And I will have t dt over here. So all these equations work only if acceleration is constant, or else it won't work. Good evening, Sadia. So what is the limits? When my time was 0, my distance traveled was 0. But when my time was t, my distance traveled was s. When time was 0, I have not traveled. But when I have waited for t time, then my displacement which has occurred is s. So that's why the limits. What is integration of dx? It is just x. So I'll put 0 over here and s over here, which are the limits. U is a constant. Dt's integration is just t. 0 over here, t over here, plus a into t dt's integration. X raised to n formula. X raised to n plus 1 by n plus 1. So t raised to 1 plus 1 by 1 plus 1. So it is t raised to 2 divided by 2. Okay, I'm using x raised to n formula. For those of you who forgot about it, just a quick recap over here. X raised to n dx integration is x raised to n plus 1 divided by n plus 1. That is the formula which I am using. Here t is like x, n is 1 in this particular problem. So what do I get over here? This is just going to be, first substitute s and then substitute 0. This will be u, then first substitute time, then substitute 0, then a, then first substitute t, then substitute 0. That's it. So everything minus 0 is just that everything, because 0 will not make a difference. So s will be nothing but ut plus, I can just write it as half a into t square. So this is the second equation of kinematics. What is this? This is the second equation of kinematics. Yep. No problem, Sadia. Yes, this full class will be recorded. Before I could answer, you said bye also. Very good. Okay. At this point, everybody clear about this? How the second kinematic equation has come? Shall we go to the next kinematic equation? Shall we go to the next kinematic equation? Observe this now. We'll go to the next kinematic equation. Next kinematic equation, what I'll do is I will take the dot product of the velocity with itself. I'll take the dot product of the velocity with itself to get the third kinematic equation. Now I know the first kinematic equation was u plus at. So v was actually u plus at. So each of this velocity is nothing but u plus at dot u plus at. Now, very important thing, guys, which you should know. If I have a vector, I take the dot product with itself. It will be a into a into cos 0. What is cos 0? Cos 0 is 1. So a into a is basically a square. So the dot product of a vector with itself is the magnitude square, is the square of the magnitude of that vector. So what I will get, v dot v will be v square. I have to multiply each term with everything. So let's see what are all terms we get. U dot u plus a bar dot a bar into t square plus u bar dot a bar t, but this I will get 2 times because u bar into at into u bar. I'll get it 2 times, so that's why 2 times of u bar dot at. What is u dot u? Just like that, it is nothing but u square. Perfect. Plus a bar dot a is nothing but a square, and I will have t square over here, or I can do one more thing. Let's do one more thing. Let's just take a common. Let's just take a bar common. Okay. In fact, let's take 2a bar dot common. And then what will I get inside is over here, I will have a bar t square by 2. Check this out. 2 cancels a bar dot at square. So that is perfectly fine. Nothing wrong over there. And over here, since I have taken 2a bar common, what I am left with is just u bar t. Just check this out. I'm just left with u bar and t. Is that right? Everybody with me? Perfecto. Hello, Kevinash. Now, what is this? What is this bracket term inside? Come on, quickly answer in the chat box. Quickly answer in the chat box. What is this exactly, my dear warriors? Yes, it is none other than displacement. Correct. So guys, this is 2a bar dot displacement, and this is what you get as v square is equal to u square plus 2as. Perfect. This is the answer that you get. Final velocity square is initial velocity square plus 2a bar dot s bar, and this is called as your third kinematic equation. This is called as your third kinematic equation. Correct. Very good, Divakar, Mesu, Lucifer, Herborine. Awesome. Awesome. Okay. There is a dot product between acceleration and displacement. Usually it doesn't matter in one-dimensional motion, but in two dimension, that dot product matters. Okay. Otherwise, you don't really worry about the dot product. Okay. Many people did not know how this derivation happens, why this dot product comes. So this is the actual derivation, guys, of all the kinematic equations. After this, you will never ever face problems. Moving on to the final derivation, and that is for something called as the nth second. Something for the nth second. See, when I say, fifth second, what does it mean? What does it exactly mean? Fifth second means from, take 1 second before 5, what is it? 4. From 4 to 5 seconds. That is what fifth second means. Similarly, if I say for example, 72th second, it means from 71 to 72, the previous second. Understand that. Similarly, if I tell 6.3th second, 6.3th second, it means from, take 1 second before that, 5.3 to 6.3 seconds. That is the meaning of nth second. So in general, I can say when I use the word nth second, it means from n minus 1 to n seconds. From n minus 1 to n seconds. That is the meaning of nth second. Correct. So here we get the final equation of motion, the fourth equation or the last equation of kinematics. Say for example, you start with some velocity at some time, and after some time, let's say this is n minus, sorry, this is n minus 1, and this is, let's say, n. So this is your nth second, if you think about it. This is basically nth, in nth second. In that nth second, how much I have displaced? How much I have displaced? This is the displacement. This is the displacement in nth second. This is the displacement in nth second formula which we are going to derive, right? Okay, so in the previous second, how much did I displace? That is the displacement in nth second. Okay, displacement in nth second. Okay, okay, okay. Let's see, let's see. Okay, so the formula, displacement in nth second. This displacement in nth second, can I write it as the total displacement till n minus the displacement till n minus 1? Like, think about it, this much part will be nothing but this whole part minus this part. This minus this will give me this, right? So can I just write it as, displacement till n seconds minus displacement till n minus 1? Does that make sense to all of you? Everybody give me a thumbs up. Understood till this point? Okay. Sagar, the board has released notice that it will not include any PYQ or sample paper in 2025 exam. Please correct the protection from the scam or rumors. Okay, thank you, Sagar, for that information. I will have a look into it and I will see if that matter needs to be discussed. Okay. So what is the displacement in the nth second? Sorry, what is the displacement till n seconds? Use second kinematic equation. Use our second kinematic equation, ut plus half at square, that's all. So this will become u, instead of t you will put n, plus half a n square, this is the first term, minus, instead of time now you put n minus 1. So u into n minus 1 plus half into a into n minus 1 the whole square, right? This is what you're going to get. So now see what and all terms will be there, un plus half an square minus, this will be un will be there, with negative, negative will become positive, so plus u will be there. Then first term will be, just check this out, this is minus a by 2, and n minus 1 whole square will be n square plus 1 minus 2n. These are the terms that you are going to get. A lot of terms are going to get cancelled, like un will get cancelled. So this particular un and this particular un is just getting cancelled. So I'm just left with half a n square minus, no, minus is gone. So plus u, and then over here minus a n square by 2, minus a n square by 2, minus a by 2, and minus minus will become plus, so plus a n. In fact, a n square by 2 and half a n square, this and this is also getting cancelled, guys. Just check this out. So you should get u plus, I can take a by 2 as common, a by 2 as common, and then I will have 2n, because that 2 and that 2 will get cancelled, minus 1. That should be the final answer. So that is the displacement in nth second. That is the displacement in nth second, guys. That is the derivation for this. This is your fourth kinematic equation. This is your fourth kinematic equation, u plus a by 2 into 2n minus 1. Yep, everyone, till this point clear? Very good. So in your school or maybe in your boards or something, you might have seen all these equations, and then you might have also seen some random derivation. Displacement is final velocity plus initial velocity by 2 into time, where this is basically called average, and they tell v plus u by 2 into t. Guys, this derivation is ridiculous, because this is only valid if the velocity changes uniformly And how do you know, first of all, when velocity changes uniformly, the average is initial plus final by 2. So there needs to be a mathematical way of first proving that fact first, that when you take average, you can just take initial and final value and then divide by 2. That doesn't work always. Remember that. You can't just say average is initial plus final by 2. That is wrong, guys. That is only true if it increases at a uniform rate. And why does that happen when it increases at uniform rate? So that proof is again lengthy. So this is just assuming certain things and taking things for granted. So that is why we do not generally, use these kind of derivations in JEE. That is okay for school level. School people will, oh wow, very nice, very nice, very nice, very good. It becomes very easy. But the actual derivation is right over here in front of you. Okay, all these are the actual derivations. Clear? Shall we go ahead? Shall we go ahead, my dear warriors? Let's start with some problems, and these are your equations of motion. V is u plus at, s is ut plus half at square, v square is equal to u square plus 2s, snth is equal to u plus a by 2 into 2n minus 1. And when we study motion under gravity, we'll use g, or the acceleration due to gravity, instead of a. That's the only change. Okay, now when you solve using kinematics, certain important things which you need to remember. First thing, check if acceleration is constant. Sometimes it looks like the acceleration is constant, but it is not. For example, I have seen a problem where a body is accelerating at 5 meters per second square like this, and then after some time the acceleration changes the direction to 5 meters per second square like this. So from here to here it is different, from here to here it is different. So as a whole, do you say that the acceleration is constant? As a whole, for that entire motion, will you say that the acceleration is constant? Obviously no, because the direction is changing. So it looks like acceleration is constant, but it is only constant by magnitude, not by direction. So for this problem, you cannot use kinematic equations. Keep that in mind. Okay, so that is why I said check if acceleration is constant. Very, very important. Hello Samuel, hello Anime God. Next important thing, assume some positive sign convention. Basically sign convention, positive direction. Next thing, write and draw all the variables, or basically all the parameters with the proper sign, with proper signs. If you have chosen right side as positive, all the vectors towards the right side will be positive. If you have chosen downwards as positive, so all the vectors pointing downwards will be positive. But stick to it. All the unknowns will turn out with proper signs, will turn out with proper sign after solving. Sometimes the kinematic equations may not be enough. Okay, sometimes the kinematic equations will not be enough. So if equations are not enough, then either make more equations, make more number of equations, or use additional information to get those unknown variables. You have to make some equations. Maybe sometimes you have to use law of conservation of momentum. Sometimes you might have to use, some additional piece of information. This distance to this distance was traveled in this time, or the acceleration is twice as that of the previous acceleration. Something will be given somewhere. Or this time that was traveled in exactly half the time as that of the previous time. something or the other will be given to you. So use those additional pieces of information to get those equations and finally solve those things to get all the unknowns. Okay, that is a basic flow for solving any kinematic equation problems. So let's start with it. Here is the first question coming up on your screen. Read the question carefully, draw the question in your rough sheets, and then let's proceed, because that's what I told you. Always draw, always draw everything. Okay, assume some direction as positive, check if acceleration is constant or not. I can see that there is some retardation, deceleration, acceleration. Well, one and the same thing, just a way of talking about it. When I say retardation or deceleration, that means the speed is reducing. That's all. Okay, so my dear warriors, alliance, in this particular problem, there is a retardation of 4 meters per second square and it is constant, perfectly okay. And the driver of the car, let's just take this direction as positive. Let's just take this as the origin. The driver of the car, which is going at 20 meters per second when it was at x equals to 0. So this is 20 meters per second at t is equal to 0. Write down every piece of information. Applies the brake, seeing a red signal. Signal is at x equal to 100. Find a distance after 6 seconds. Okay, at 6 seconds, t is equal to 6. Maybe the car has displaced some amount. How much is the displacement? I do not know that. I just do not know that. In fact, I'll find it out. Okay, if the brakes produce a retardation of 4, the retardation is 4. That means the acceleration is not in the front direction, it is in the backward direction. So that is why I will show it like this, opposite to the velocity, because I'm slowing down. Whenever you slow down, velocity and acceleration are opposite in direction, right? Okay, perfect. So which equation will I use? I think the second kinematic equation, which is S is equal to ut plus half at square. What is initial velocity? 20. How much time? Well, I think they have told 6 seconds plus half into acceleration is minus 4. Time is nothing but 6. So 6 square. So what is 20 into 6? That's 120. Minus 4 by 2 is basically 2. 6 square is basically 36. So this is nothing but 120 minus 72. 120 minus 72. So how much will this become? How much will this become? This will just become 48 meters. This will just become 48 meters. So it has traveled how much? Basically 48 meters. Very good. Channel 11, you can check my old lectures on derivatives and integration. Hi Karthik, don't spam. Till this point, is it clear? Yes. So the question is, find a distance of the car after 6 seconds. So it is basically 48 meters it has traveled from the original position. It has not yet crossed the signal. The traffic signal is somewhere over here. The traffic signal is somewhere over here. Okay. So the traffic signal is somewhere over here. It's much, much ahead. It is much, much ahead at 100 meters. It has fallen short by 52 meters. Correct. Okay, straightforward. Moving on to the next question on your screen. A particle starts from rest. Actually, again, the levels are not seen over here. I don't know why it went off. Actually, the level was supposed to be mentioned here. So it is not seen, but actually in the PDF, you will see it, because if you see the actual original PDFs, right, it is right over here. So whatever I'm writing, probably it's getting hidden, okay, and behind this banner or that toolbox. So all the levels are mentioned right over here. So don't worry, guys. Okay, cool. A particle starts from rest with uniform acceleration a, and its velocity after n seconds is v. Okay, the displacement of the particle in the last 2 seconds is how much? Okay, let's draw the diagram first and let's understand it. This is the straight line direction. This is x. Particle starts t is equal to 0 from rest. Okay, so t is equal to 0. It was at rest and it has some acceleration. Okay, it has some acceleration constantly. So constant acceleration means very good. After n seconds, the velocity is v. After n seconds, so at t is equal to n, the velocity was v. What is the displacement in the last 2 seconds? Last 2 seconds, that means from here to here. So t is equal to n to t is equal to n minus 2. This is what is being asked. How much is this particular displacement? Let's say I call it as x. Question is, how much is this x from n minus 2 to n? Is this point clear till this here? Yep. Very good. Very good. Okay. Yep. So, my dear students, first of all, what will you do? I think the answer should be in terms of A, N and V. That is something which should stick in your head. You can't have a new variable being introduced suddenly into the problem. It has to have those old variables only. Okay, whatever is given. You can't introduce some assumed variable. Okay, so what and all equations can you think of? Velocity is given, time is given. So I think we can write it like this. V final is initial velocity plus acceleration into time. Final velocity is V, initial velocity is 0, acceleration A, time is basically n. So V is basically A into n. This is one equation which I'm getting. Okay, but I can't do much with it. I want to find displacement in the last 2 seconds. So if I had to write down what is x, it is displacement till n seconds minus displacement till n minus 2. Displacement in n seconds, displacement till n minus 2 seconds. Whatever is remaining is basically x. Agree with this? So what is displacement till n seconds? Ut. U is 0. So 0 plus half a n square minus initial velocity again 0. So 0 ut plus half a t square plus half into a into n minus 2 whole square. Perfect. So let's see what do we get over here. Okay, let's see what do we get over here. We get a n square divided by 2 minus over here a by 2, and then we have n square plus 4 minus 2 2s are 4, 4n over here. Great. Let's further simplify this. What do we get? We'll get this as a n square by 2. First term is a n square by 2 with a negative sign. Next term will be minus 4a by 2, which is basically minus 2a. Last term will be minus minus will become plus. So plus 4 by 2 is 2. So 2a n, that is what I get. A n square by 2 gets cancelled. So I will be left with just this. In fact, in that also 2a is common. 2a is basically common, and I will have it as n minus 1. But wait a minute, right over here, v is equal to an. That means a is equal to v divided by n. A is equal to v divided by n. So instead of a, why not put it as v divided by n over here? V divided by n over here. So this will be 2v by n into n minus 1. 2v by n into n minus 1. That is the answer for what is it? Displacement x. So that is the final answer. 2v by n into n minus 1. Everyone? Very good, Grishma. Hello, Yugesh. What is the difference between retardation and deceleration? Okay, it's the same. It's synonyms. Okay, it's just synonyms. It's like I'm very enthusiastic. I'm very excited. It's the same thing. It's just a synonym of. Okay, some books will use retardation. Some books will use deceleration. Don't get confused. It means the same thing. That means reducing speed one by one. Reducing speed. Okay, after some time. Okay. Thank you, Yugesh, so much. Thank you, Yugesh, so much. Moving on to, oops, what did I just click? A car starting from rest travels 10 meters in the first second. Find the distance traveled from 5 seconds to 7 seconds if the car has constant acceleration. Very interesting question, guys. And let's see how do we do this. Okay, again, start with the diagrams first. Without diagrams, you cannot do anything. So this is your x-axis. Car travels from rest. Okay, starts from rest. So at t is equal to 0, you are at rest. You have traveled 10 meters in the first second. So t is equal to 1. This distance is basically 10 meters. That is what has been given. Distance traveled from 5 to 7. Distance traveled from t is equal to 5 to t is equal to 7. So this is t is equal to 5. This is t is equal to 7. How much is this distance? That is the question. How much is this distance is the question. Okay, let's do this. Whatever is given, from that, what do we get? Let's understand. By the way, in this entire journey, the car is accelerating. Okay, it is clearly mentioned. that a car is accelerating. Obviously, if it has traveled from rest to something, it has to accelerate. So if I apply some equation in this part, maybe I might get the acceleration. Oh, I know the displacement, I know the time, I know what to do now. I can use the second equation, S is equal to ut plus half at square. Displacement is 10, initial velocity is 0, acceleration I don't know, time is basically 1. So from this, take 2 on the other side, acceleration will be 20 meters per second square. Perfect, I found the acceleration. Now what I will do, I will find how much was the displacement till 5 seconds. I will also find how much was the displacement till 7 seconds. If I know this, subtracting that, I will get x. That's all. So what is the displacement till 5 seconds? Use the same thing. Ut is 0 plus half into acceleration is 20 into time is basically 5 square. What is the displacement till 7 seconds? Ut is 0, half, acceleration is 20, displacement, time is basically 7 seconds. So 7 square. So subtracting these two, what I will get is x. Subtracting these two, what I will get is x. So this minus this. So take the bigger number and then take the smaller number. So I think you will have half into 20 multiplied by 7 square minus 5 square. Is that right? Everybody understood? Everyone? Clear till this point? Very good. Very good. Very good. Okay, so what next? What next? Yes, solve this. How much will this be? So this will be 20 by 2 is basically 10 multiplied by 7 square is 49 minus basically 25. So 49 minus 25, that is 24 into 10, that is basically 240 meters. So the displacement in the last 2 seconds from 5 to 7 is nothing but 240 meters. Cool? Got it? Okay, Abhinav, point taken. Let's see if I can put it up. I will see if I can put it up somehow. All right. All right. So now I hope you are getting the idea of how to use kinematic equations. So I have solved quite a few problems where we have used kinematic equations in different ways. One or the other kinematic equations have been used. Another interesting question, I think this should be level 2 question or something. So this was asked in JEE Mains 2024. A body starts moving from rest with some acceleration, moves S1 in the first P minus 1 seconds, S2 in the first P seconds. Then what is the total displacement in that will be made in how much time? So the total displacement S1 plus S2 will be made in how much time? That is the question. So the question over here was, what is the time? All right. So read the first piece of information. With acceleration, displacement is S1 in the first P minus 1 seconds and it starts moving from rest. Initial velocity 0. Acceleration is basically A. Displacement is basically S1. Time is basically P minus 1. So I think the best thing to do is use S is equal to ut plus half at square. Displacement is S1. Initial velocity is 0. Acceleration is A. Time is basically P minus 1 whole square. So basically S1 will be A divided by 2 P minus 1 whole square, which can be also written down as P square plus 1 minus 2P. This is S1. Similarly, think about it. For S2, which takes P seconds, I can write S2 is equal to, using the same kinematic equation what I have used here, same thing I can use it here, will be ut plus half into A into P square. Therefore, S2 will be just half A P square. That's all. Now comes the last part. For this displacement, time taken is t. So if I had to do S1 plus S2, initial velocity is 0, acceleration is A, time taken, I don't know, that's what I have to find. If it is neither S1 nor S2, but a total displacement of S1 plus S2, in that displacement or for that displacement, how much time do I take? That is what the question is asking us. That is what the question is asking us. Okay. So let's try this out, my dear warriors. What is S1 and S2? We know it from here. So just substitute the values. All you need to do is substitute the values. So let's substitute. S1 is nothing but a p square by 2 plus a by 2 minus 2 cancels ap, and S2 is just a p square by 2. Okay, this is equal to a t square by 2. First of all, I can see a cancels. P square by 2 plus p square by 2 will become just p square. P square by 2 plus p square by 2 will just become p square plus half minus p is equal to t square divided by 2 is equal to t square divided by 2. Multiply by 2 on both sides, so it will become 2p square plus 1 minus p is equal to, sorry, minus 2p is equal to t square. So take the root, guys. That's it. I think answer D will match. Answer D will match. Perfect. That is the answer. 2p square minus 2p plus 1. It's exactly the same thing. You just take the root, you will get the answer. Is that right? Understood? How do we solve this question? Yes, answer D. Sir, 30 plus in advanced physics with HCV plus advanced PYQ. What is 30 plus in advanced physics? You're saying marks? 40 plus in only HCV and advanced PYQ for 40 marks. Oh, unknown. 30 to 40 marks. That means you're saying around 8 to 10 questions just with HC Verma and advanced PYQs. Maybe. Almost. But when I say PYQs, you have to solve all the PYQs right from 1970s. Not just the recent PYQs. Then if you're solving all 30, 40 years PYQs, then maybe yes. Yes, it is possible. Unknown. Okay, cool. Let's move ahead. Let's move ahead for graphs and derivative related questions. Okay, ready for it? Ready for it? Because graphs and graph reading, graph based questions and non-uniform based questions are also very, very common in your JEE mains or even in advanced exam. How to get 270 plus in JEE mains? Okay, I'll tell you how to get it. It's there right on the app. It's there, sorry, right on the channel. Just go to live. Do you see over here? JEE 2025 strategy. Okay, I have given a proper strategy for not 99. Actually, 99 is like the bare minimum. You watch this video, I've given the proper strategy for 99.9 percentile only. So you check this video out, you will see proper guidelines and timelines, everything I have mentioned, when to do what. So watch this video, that will help you a lot. Okay, everything has been mentioned. All right. All right. So let's go to graphs. Full of Josh, my dear warriors. Full of Josh, my dear warriors. Ready for it? Okay. Chalo, come on, guys. I need full energy because my back is hurting a lot today. I don't know. Is it because of standing every day or teaching every day like this? I'm not sure. But my back is hurting and I just feel like sleeping right now, lying down to give my back rest. But still, I'm standing for all of you so that I can, cover up the entire chapter in this one go. Okay. So, need some appreciation, need some likes for that, need some comments for that, and your Josh and full of, your replies in the chat box, whatever the answers are there of the questions. Okay. So, let's begin, guys. So, okay. First, I will talk about the calculus-based relationships, then we'll go to the graphs. One thing you should be clear is a rate of change of y with respect to x is the same as derivative of y with respect to x, which is the same as differentiation of y of y with respect to x, which is also the same as the slope of y versus x graph. Okay, all these things means the same thing. All these things means the same thing, and what they are referring to is dy by dx. Slope, differentiation, derivative, rate of change, instantaneous value of something. Instantaneous value of something. Right now I'm all right, Yugesh, but hopefully after the lecture I'm all right. Okay, so let's see. So dy by dx is nothing but whenever you have a graph like so, y versus the x-axis, maybe the graph is something like this, you draw a tangent at any point, and you measure the theta value. So dy by dx is how quickly it is changing up or down. So that is basically your tan of theta. That is the concept of derivatives. That is basically the concept of derivatives, where you draw the tangent and you measure the slope. This is also called as the slope of the graph. This is one basic thing which you should obviously know. The second basic thing which you should also know is, if you are given the exact opposite now, again y versus x, there is some random graph over here, and you are being told between this point and this point, let's say this is L, this is U, what is the area under this particular graph? What is the area under the y versus x particularly graph? That is given by integration of that y with respect to dx from the lower limit to upper limit. This L, remember, it is actually called, this is, this is basically called lower limit. This is called as the lower limit. This is called as the upper limit. Upper limit. Upper limit is over here. Lower limit is over here. This is the area under that particular graph. Sometimes you are going to need that as well. Okay. Sometimes you are also going to need that as well. And remember, this particular integration, this is also called as your integration, is nothing but the antiderivative, is antiderivative, meaning if the derivative of something gives you something, if you flip it, you will get back the original function. Like for example, the derivative of sine of x gives you basically cos of x. Sine of x gives you cos of x. Similarly, sine of x plus any constant, if you take the derivative, you will get basically cos of x. You do the exact opposite of it, meaning you integrate cos of x. You integrate cos of x with respect to x, you will get back the original function, which is sine x plus c. That is the meaning of integration, which is antiderivative. You take the derivative of sine, you get cos. So the integration of cos is basically sine. These are the basic things which you should probably remember. I'm just trying to do a small recap of it. Okay. So now, why is this important? Because you have seen that wherever instantaneous velocity, instantaneous acceleration is there, you are somehow or the other using the concept of either derivatives or integration. So let's talk about it. Whenever you have position and you want to find velocity, and from that you want to find acceleration, this is how the logic goes. From position to go to velocity, just take the derivative of it. So basically, you just find dx by dt. Hold on, I'll write it down like this. This velocity comes out as dx by dt, which is the slope of x versus time graph, which is the slope of position versus time graph. Okay, whenever you are taking dx by dt, just look at it over here, just like dy by dx. It is the slope of y versus x graph. Exactly same way. you will see that the slope of position time gives you velocity. So I'll just put it over here also for you. I'll just put it over here for all of you. This is the graph of position versus time, and you have been given some random graph like this, and you draw a tangent over here, and this is basically theta. So the slope of this particular graph gives you the velocity. Exact same thing you replicate over here from velocity to acceleration, my dear warriors. Acceleration is rate of change of velocity, which is also the second derivative of the position with respect to time. Second derivative of the position with respect to time. And when you're doing that, you are essentially finding the slope of velocity versus time. Slope of velocity versus time, meaning if you have been given a graph of velocity with time and it goes something, let's say like this, you again draw a tangent. You again basically draw a tangent to the velocity time. You measure the slope, which is tan theta. You will get the value of the acceleration. That is what it means. That is what it means. So from position, you can go to velocity. From velocity, you can go to acceleration by taking the derivative of this. Just to show you a simple example. Imagine I tell you x is equal to t raised to 3 minus 2t plus 4. This is your function. I want to find the velocity or I want to find the acceleration. What will I do? I'll just take the derivative of this, as simple as that. So if I want to find velocity, it is just taking the derivative of the position. So take the derivative of this, which is t cube minus 2t plus 4. So what is the derivative of t cube? It is 3t square. Use x raised to n formula, which is nx raised to n minus 1. So 3 comes out, t's power will be reduced by 1. Minus 2 into derivative of x is 1, derivative of t is basically 1. So it is just 2 into 1. Constant's derivative is 0. So hence the velocity will be 3t square minus 2. You can see the velocity is changing with the time. Somebody gave me the position that at this time, this is the position. At this time, this is the position. This is the equation which it is following. I don't know the graph, but some equation it is following. So you can find the velocity at any time and you can see clearly it is not a constant value. It is not a constant value. If somebody asks you what is the initial velocity, you are just going to put time as 0. So the initial velocity will be 3 into 0 square minus 2. Therefore, the initial velocity will be minus 2 meters per second. This minus sign indicates that it is not going towards the right side, but it is going on the negative x-axis. That is what it is telling me. That is what it is telling me. Now, if I had to find acceleration in this scenario, which is derivative of velocity, what is that velocity? We just figured it out over here. It was 3t square minus 2. So therefore, the acceleration will be 3 as it is. Time square's derivative will be 2t raised to 1. I'm using nx raised to n minus 1 formula. Okay, so minus 2 is a constant, so derivative is 0. Therefore, the acceleration is 60. If they asked you what is the initial acceleration, if they ask you what is the initial acceleration, then you'll just put 0 over here. So it will just be it will be just 6 multiplied by 0, which is 0. So it has no acceleration initially. The acceleration picks up. In fact, even the acceleration is not a constant like the velocity. So in this problem, tell me, can you use kinematic equations? Can you use kinematic equations? The answer is a big fat no. Why? Because acceleration is not a constant. I hope this problem cleared how this particular thing goes. You have taken the derivative 2 times. You can also see a simple graphical problem like this. Say, for example, there is a graph given over here to all of you. This is position, this is time, and the graph given over here is something, let's say, like this. And they have told that if you draw a tangent here, this is 30 degrees, okay, or just do that thing. Something like this, okay? Now, they have told that if you draw a tangent here, then it basically makes 30 degrees. And if you draw a tangent here, okay, it makes an angle of 60 degrees. Okay, and where have you drawn the tangent also matters. This is at this particular point, let's say at 2 seconds, and let's say this is at, let's say, 5 seconds, some random times. If now in this question it is asked what is the velocity at time is equal to 2 seconds and 5 seconds, what will you do? If the question now says what is the velocity at 2 seconds and at 5 seconds, here is what you're going to do. Velocity is nothing but the slope of that graph, slope of position versus time graph, So slope means tan of the angle made by the tangent to the graph. This is the tangent, it is making 30 degrees. So it is basically tan 30. What is tan 30? It is 1 by root 3. So answer is 1 by root 3 meters per second. That is the velocity at this point. If they ask you what is the velocity at 5 seconds, you will just say it is tan of 60. That's it, tan of 60. As simple as that. So what is tan 60? It is root 3. So root 3 meters per second is the velocity. As simple as that. Now, imagine there was one more question in this, and they asked you what is the average acceleration from 2 to 5 seconds. That was the question. What is the average acceleration from 2 seconds to 5 seconds? What will you do? Think about what is the definition of average acceleration. It is change in the velocity upon the time. Change in the velocity upon the time. So at 5 seconds is the final, at 2 seconds is the initial, final minus initial by time. Velocity at 5 seconds is root 3. Velocity at 2 seconds is 1 by root 3. Whole thing divided by the time interval from 2 seconds to 5 seconds. How much is it? It is just 3 seconds, my dear warriors. So if you take LCM, it will become root 3 into root 3 minus 1 divided by root 3, and this 3 also will come over here. So this will become just 3 minus 1 by 3 root 3, which is nothing but 2 by 3 root 3. 2 by 3 root 3, as simple as it. Okay, so this is nothing but the average acceleration, 2 by 3 root 3. Got it, everyone? Sure, you can use my old sessions, even the last year sessions also you can use. They have very good questions, for bits and even this year's sessions also you can use. Honestly, we are out of bandwidth because I'm already involved in NEET and JEE channels both. I wish I could take more sessions, but I'm running out of bandwidth. Plus, I have my own batches, and we are taking big sessions. Angle will be given in the question, Harbour. Yes, without the angle, you cannot solve the question. Definitely, without the angle, you cannot solve the question. Right. Cool. So understood how to solve these questions on derivatives. Okay, from here to here. Now let's go exactly opposite, and that is integration. And that is basically your integration. So if you go from here to here, that is antiderivative, that is integration. So what you get is delta x is integration of velocity with respect to time from t1 to t2, and this is nothing but the area, just put it over here, this is nothing but area under velocity versus time gives you displacement. Change in position, delta x is displacement, remember that. X is position, delta x is change in position, which is displacement. This is very important. Same thing you can go over here and do it. You will write not v, wrong. If you write v, it is wrong. It is delta v is integration of acceleration with time. So this is from t1 to t2. So I can say area under acceleration versus time gives me the change in the velocity. Change in velocity. Graphically, if you want to see it, this is time, this is acceleration, this is time, this is velocity. So you have some random graph, you basically are finding the area under it. You're basically trying to find the area under it. So from here to here, this area under velocity time from t1 to t2, this area gives me the displacement. This area from, let's say, here to here, if I find how much this particular area is from t1 to t2, I will get the change in the velocity. That is the graphical interpretation of that integration. This is exact reverse process of the derivatives. Let's take some examples so that you guys understand it. Imagine somebody tells you, listen, the acceleration is t square and at t is equal to 0, basically initially, velocity is 2 meters per second and position is 0 meters. Question is, find velocity's function and position's function as time. How is position and velocity dependent on time? That is the question asked to all of you. Let's try to solve this question, my dear students. You have to go exactly reverse. That is very well understood from this particular part, because where is it? If acceleration is given to go to velocity and to position, I have to go via the integration approach. And this is the formula for the integration. Supriya, at different years, they were called different things. I think a long time back, it was called as rank accelerator or rank booster or something. And this year, we had conducted, we did not call it any series name, we just called it JEE Advanced. JEE Advanced mock test, JEE Advanced problem solving. That is what it was called, Supriya. Okay, so you can check it out just by doing a simple search also. Like, you don't even have to know the series name. We did not give any name as such. You can just search for JEE Advanced over here, physics. Don't search here, search here. There are two search bars. On the mobile, this is not visible. Only on the website, this is visible. So just click over here. You will see JEE Advanced. Okay. So you will see JEE Advanced related sessions right over here. I hope that is clear. All right. So going back to this particular problem, since from acceleration I can only find the change in the velocity, okay, fair enough, which is acceleration with respect to times integration from t1 to t2. So what is the change from final to initial? Initial was 2, so final minus initial is the change. Acceleration is t square. Instead of a, I'll put t square dt. Initially, time was 0 when the speed was 2. Finally, the time is t. That's how I will put the limits. Initially, the speed was 2. Finally, at time t, velocity was v. That's how I substitute the values in this particular formula. So, v minus 2 will be t square's integration will be t cube by 3 x raised to n plus 1 upon n plus 1. That's it. You have to put the limits, of course, 0 to t. When you put the limits, again, you are going to get the same thing, undoubtedly. So it will be t cube by 3 minus 0 cube by 3. So it is just t cube by 3 after all. So take that 2 on the other side. So it will be t cube by 3 plus 2. So that is the velocity's function as time. Velocity is dependent on time. Great, we found that out. Next thing, we have to find position. So delta x is integration of velocity with respect to time from t1 to t2. Change in the position. Final position is x. Initial position 0. What is velocity? This whole big function. So integration of t cube by 3 plus 2, the whole thing dt. Initially time was 0. Finally the time is t. That's all. That is what I will substitute it as. Okay, instead of velocity, I have substituted this value over here. Initially, time was 0. That time position is 0. Finally, the time is t. The position is unknown, some variable x. So, x will be equal to, integrate this. This will become t raised to 3 plus 1 by 3 plus 1, which is t raised to 4 by 4. 3 stays as it is. Plus 2 dt's integration is 2t. And then put limits 0 and t. upper limit and lower limit. If you put t and then put 0, that 0 term will anyways vanish. So I'll be left with t raised to 4 by 12 plus 2t. That is position as a function of time. That also we have got by double integration. By double integration. Why are we ignoring constant of integration? Tell me one thing, when you put limits, will you have constants of integration? When you have limits, will you have constant of integration? No, right? So that is the reason why I gave you these formulas without the constant. Without the constant. See, if the same formula, if you write it without the limits, then you will write x is equal to integral v dt plus c. So you will solve it only in a very different way. You will find the constant, then substitute it back. But I want to avoid that process. I want to get rid of that constant. So that's why I put limits. So when I put limits, it becomes definite integration. It becomes definite integration and I don't need constants. Right? Is that okay, Supriya? I hope that is clear. Great. So we have seen the relations as such, but there is one more relationship which I want to teach. One more relationship which I want to teach. What is that relationship? Observe this carefully. Okay, observe this carefully. Imagine acceleration is written down as dv by dt. I can use chain rule. I can use chain rule. And instead of dv by dt, I can write it as dv by dx into dx by dt. Dx anyways cancels. All I have done is I have used the chain rule of derivatives. So hence what will happen? This will just become dv by dx. And instead of dx by dt, what is dx by dt? That is velocity. So this also becomes a very interesting looking formula in many cases. In many problems, you might have to use this. In many problems, you might have to use this relationship. Acceleration is dv by dx into velocity. No, relative velocity will have a separate class, not in this class. We'll do it separately. Say for example, my dear warriors, we had, okay, um, let's say velocity given as a function of x. Let's say velocity is given as x cube. Find acceleration as a function of x. That was the question. How will we solve it? Question is acceleration as a function of x. So acceleration is dv by dt, but in my expression, whatever is given, it's only in terms of x, no time is there. So instead of that, I can also use it is dv by dx into v. What is the dv by dx? Okay, instead of v, I will put x cube over here and this v as it is. Oh, this v also I can substitute. This v is also x cube. Okay, so this is the derivative part. This is just directly substituting velocity as x cube. What is the derivative of x raised to 3? It is 3 into x square. 3 into x square. And this is basically x cube. So therefore, I will get the acceleration as 3 into x raised to 5. So acceleration is a function of x. Solved. So this is how sometimes you might have to use this relationship. Cool? Very nice. Awesomeness. So now that we have learned this and we have also seen the graphs part also, I just showed you all the graphs right over here. I also showed you the graphs part right over here. So I think it's a good time that we start with some questions. Let's start with some questions. Coming up on your screen, here it is. Find the velocity. Oh, one thing I can just show you in graphs. One thing I can just show you in graphs. Very, very important. This is velocity. This is time. If I show a straight line graph, what do you understand by this? If the graph of velocity time is like this, a straight line, what can you understand? It has a constant slope. The slope is basically constant. And what is the slope of velocity versus time? What is the slope of velocity versus time? It is acceleration. That means the acceleration is the slope is constant. Acceleration, which is the slope, is also constant because the slope is nothing but the acceleration of velocity time. Okay. And then if I mark certain points over here, this point refers to when the time value is zero. When the time value is zero. So that is basically initially what is the velocity. Obviously, that is u. Initially, what is the velocity? That is nothing but u. After some time, what is the velocity? Well, if I go like this, I will get the velocity over here. Now, any equation of a straight line, any equation of a straight line always looks like this. Y is equal to c plus mx. C is the distance where it intersects the y-axis, m is the slope, y is the coordinate, x is the other coordinate. Here, the y-axis coordinate is none other than the velocity itself. The constant c, which is the intercept on the vertical axis, is this distance, which is nothing but u, plus the slope of this graph is nothing but a, and the displacement, sorry, the x value is nothing but the time. The x value over here is nothing but the time. So this is how you can compare the straight line equation and the first kinematic equation. Straight line equation and the first kinematic equation. Correct? Everybody till this point clear? Very good. One more thing which I can tell you is that in this particular same graph, by the way, the slope is basically a. If you happen to measure this particular area, which can be divided into triangle and rectangle, you will end up getting the displacement. So we all know area under what is this, velocity versus time, is nothing but the displacement. So this area is nothing but the area of the triangle, which is this one, plus the area of the rectangle. So you try it out, area of the triangle plus the area of the rectangle is displacement, which is s. If you measure all the heights, base, everything, you will see one of the term will be half at square, the other term will be basically ut, and you will basically get s, which is the second kinematic equation. So these are basically the graphical ways of representing it. Now, let me tell you, there is one more interesting graph which you should know, and it is also proof for Galileo's law, which says that whenever you have a body which starts from rest, starts to accelerate uniformly from rest, the displacements in successive equal time intervals are in, I will tell you what it is. I'll tell you what it is in a bit, but after showing you the proof first. So look at this, guys. What I'm going to do is I'm going to just take a graph. So this is time, this is velocity. A body which starts to accelerate uniformly. Starts means it has just started from rest. So obviously it has to be a straight line, and uniformly means it has to be a straight line. So this is the graph, okay, of the velocity versus time. Till this point, everybody clear? Let's take equal time intervals. Let's just take equal time intervals and see what do we get. So let's say this is T. I'm just taking roughly. This is also T. This is also, I mean, think of it like this. Like this is basically T. This is basically T. Same thing. This is basically T. So point wise, this is T, this is 2T. Okay. And then same distance ahead. So same time interval T. Same thing over here. Okay. This is the next interval, which is T. So T, 2T, 3T, 4T, like that. You continue. Now let's measure the areas, guys. Because area under each graph, what will it give me? What will the area under this particular graph give me? It will give me the displacement, right? So check this out. If I just, oops. If I just happen to measure how much is this particular area right over here, right over here. If I call that particular area, my dear warriors, as let's say capital A, as capital A, in this particular part, can you see how many such triangles will fit in? Can you see how many such triangles will fit in? Just check this out. 3 triangles will fit in, guys. So this will be A, this will be A, this will be A. In this particular part, can you guess how many triangles will fit in? This will be A, and A. So I think 5. I think 5. In this part, just check this out. Just check this out. How many such triangles will fit in? 1, 2, 3, 4, 5, 6, 7. Do you see 1, 3, 5, 7, 9, all odd numbers? So if I measure this complete area, it is 3 times the previous area. It is 3 times the previous area. If I measure this area, it is 5 times the initial area. It is 5 times the initial area. If I measure, let's say, this particular area, it is basically 7 times of that initial area. So basically in the same time interval, you will see that the displacements are in the ratio of 1 is to 3 is to 5 is to 7, because the area under these graphs gives me displacements. So I would just say that they are in odd number ratio, odd number ratio, odd number ratio. So that's why displacement in the first time interval is 2. Displacement in the second time interval is 2. Displacement in the third time interval is 2. Okay, I can continue this. I can continue this, guys. I can continue this endlessly. This will be in the ratio of 1 is to 3 is to, and then continue this like this only, is to 5 is to, 7 is to 9 is to, like that. Okay, so they are in the odd number ratio. This is very, very important. I hope this, okay, logic is very clear. We have, you know, proved this using the areas of the triangles which are fitting into these particular sets over here, into these particular parts over here. That's all. Yeah, Divakar, this is a very, very innovative way. And let me tell you, this is my way. I have not seen it in any book. Most of the derivations, I try to do it on my own, because that's the only way you can learn and teach properly. Okay, so that's how it is. Yep. Aniket Kale, oh my God, you are asking, is it sufficient for JEE mains? My goodness, the content that I'm giving you is sufficient for JEE Advanced. We are going right from the scratch, leveling you up. Trust me, if you're following this series, and once the series stops, we will go to, mock tests, revisions, advanced bits, that, this. 100% selection guaranteed in 2025, 2026. I mean, there is no doubt about this, because we are spending our lot of time into making these lectures. We could have done 1 hour class, 3 classes. But before I start, before I say hello, before I say bye, and the momentum will be breaking. That's why we are taking as much time as it needs. I never said in the launch of the batch also that the lecture will be for 4 hours or 3 hours or 5 hours. We said it will be a one shot detailed marathon. If the lecture has to end at 12 o'clock, it will end at 12 o'clock. If the lecture has to end at 8 o'clock because the chapter is small, it will end at 8 o'clock. If we are not able to complete the chapter in one go, we'll divide it in two parts. But whatever content is needed, that content will be given to you. Theory part, everything will be taught to you. Problems, whatever you need to understand, whatever you need to understand the concept will be given to you over here. There is no compromise absolutely on that. Let me tell you that. Okay, so this is one of its kind series. I mean, forget English channels. I mean, there are few English channels here and there which try to come up sometime and they again go down. People keep coming and going. Forget English. I am telling you, we will give equal competition to any Hindi channel also. Yep. Yes, Nayana, this is for advanced as well. As we complete this series, we will also have final revision classes. And this year, I did not honestly get time to, do everything because, I joined Vedantu only in the month of December and then mains was just 1 month down the line. But this time I have time, I have quality time which I can spend with you. If you support and if you watch these series, if you spread and talk about this series and this channel to your friends and we complete this by the month of September, max to max, I'm telling October, ideally September. Imagine the time that I will get to prepare you in depth for not just mains but even JEE advance. That is what I'm trying to do over here. Yes. Okay, Naina, others? Yep. Cool. Let's move on now to some questions. Let's move on to some questions coming up on your screen. Here it is. Find the velocity of the particle at 3 and 10 and 18. Okay, straightforward question. 3 is where? Here. 3 seconds is here. Okay, 3 seconds is here. It's a straight line. So the velocity at 3 will be the slope at 3, which is the change in the position upon the change in the time. Change in the position, oops, 20 to 0. 20 to 0, guys. So it will be 20 minus 0. Change in the time. So from 0 to 5, it is basically 5 minus 0. So it will be 20 by 5, which is 4 meters per second. Whether it was 3, whether it was 4, whether it was 2, doesn't matter. This 3 had no significance here unless and until it goes outside. The velocity is constant right from 0 to 5 because it is a straight line. So you just have to measure the slope. I'm so glad, Arun, Prasad, thank you so much. Will this law be also true for free fall? Yes, Divakar, that odd number ratio law is also true for free fall, no doubt about it. 10 seconds, 10 seconds, but only given condition, it should start from rest, 0, okay? 10 seconds, that is basically over here. So I can just say V at 10, change from here to here. Final is minus 20, initial is plus 20, whole thing is divided by the time. So from 5 to 15, so I will just say 15 minus 5. So minus 20 is minus 40 divided by 10, which is minus 4 meters per second. It's negative because it's going down, which makes sense. Last one. 18 seconds. 18 is somewhere here. This is basically your 18. So we are talking about this line over here. So V at 18, final final position is 0. Initial position was 20. Check this out. Finally, it was here, which is 0. Initially, it was at this minus 20. Yeah, correct. Yes. So final is 0 minus initial, which is minus 20, whole thing divided by the time. So from here to here, from here to here, how much is it? 20 minus 15, which is 20 by 5, which is again 4 meters per second. That is the answer. Is that absolutely clear, my dear warriors? Yep. Thank you, Supriya, my old student. Soumya, my new student. Nayana vlogs, can you explain which part do you want me to explain, Nayana? Whenever you have to measure the slope, whenever you have to measure the slope of any given line, what do you do? If these are the 2 points, this is x1, this is x2, this is y1, this is y2, what do you write the slope as? The slope is y2 minus y1 upon x2 minus x1, because y2 minus y1 is this, which is delta y. X2 minus x1 is this, which is delta x. So the slope actually is how much the y changes with x. So that's all I have done over here. In the first part, when I want to find the velocity, in this part, how much did the y change? How much did the x change? That's it. In the second part, right from here to here, the y changed by this much, the x changed by this much. That's all. And in the last part, if you see at 18 seconds, check this triangle. So from here to here, the y changed by this much, the x changed by this much. That's all we are trying to do. Is that clear now, everyone? Everybody with me? Very good. Excellent. Just 1 second. Now, Naina, is it clear? V3 part is confusing. V3, na? Okay. V3. Acha, V3. Just check this. Beat 3 second, beat 4 second, beat 2 seconds. Okay. The slope is the same. This is your final at 5 seconds. At 5 seconds. And initially at 0, your velocity was 0. So y2 minus y1, 20 minus 0. Correct? X2 minus x1, which is 5 minus 0. That's all. So 20 by 5 is basically 4. Now is it clear, Naina and everyone? Okay. Soumya, partial drop is a very good option. It's a very practical option. If you are considering it, if you are not so confident of cracking it via drop, it's a very good option. But having said that, partial drop has to be taken keeping in mind that you will study and you will not get carried away by college activities. If you get carried away by college activities, then there is no point. All right. Moving on to the next question. Oops, here. Acceleration at 1 second. Oops, very simple, guys. This is velocity time. So, acceleration is slope of velocity versus time. So, velocity versus times the slope. So, this is y2, this is x2, this is y1, this is x1. That's it. Or if you want, you can also take this and this, no issues at all. So delta v by delta t. Change in the velocity 10 minus 5. Change in the time 2 minus 1. So it is 5 by 1, which is basically 5 meters per second square. Is that very, very clear how we found it? Good evening, Shailesh. Yep. Okay, right. Supriya, what to do if somebody scolds us and the mood to study only spoils? Next time, don't get that scolding. As simple as that. Mood will spoil. Next, so what multiple options you can do. Like even when I was studying, I used to get scoldings, and many students I have seen they get a lot of very bad scoldings. Like I had one student whose I won't name who did it, but the father used to scold even the mom when the kid never used to study. So that was a very, very disturbing situation. And for a year long, we struggled a lot. We had to, in fact, counsel the parents also at one point of time. So it depends who is scolding. Sometimes some brother, sister might also scold. Sometimes the teacher himself might scold. One option is stay away from negativity. Second thing is try to go to a person immediately to console yourself. Let's say, you know, somebody scolded you. Maybe you're very close to your sister, brother, or uncle, or somebody, or a best friend. Do you really think I am so bad, or do you think I'm, doing this wrong? Maybe if the friend is positive, then they will definitely help you out, or your brother, sister, whosoever it is will help you out, cheer up and change your mood. They'll tell you, no, no, listen, I know you maybe screwed up this time here. It's okay. I mean, you learned, right, this way. So you need to find some backup. You need to find some kind of a shoulder to cry on. That's when you can cheer up and get back to studies. And next time, try to not get that scolding or try to neglect that scolding, because every time you can't keep falling onto the shoulder. As simple as that. Cool. Yep. Moving on. Find the displacement from 0 to 50 seconds. Find the area basically, nothing else. But there is a catch when you find the area. The one which is on the top is always counted positive, one which is below is counted as negative. So over here, my dear warriors, this is a trapezium. What is the area of a trapezium? Area of a trapezium is half sum of parallel sides multiplied by height. That is the area of a trapezium. The sum of parallel sides. This side is parallel to this side. This side length is 40. This side length 30 minus 10 is basically 20. Understood? Sum of the parallel sides. This is one parallel side. This is another parallel side. This is 40. This is 20. Into the height. Height is basically 10. Height is basically 10. 40 plus 20, 60. 60 by 2, 30. 30 into 10, 300. So 300 is that area. But that doesn't end there. You have to also find this area, right? So what is the area of the triangle? It is half into base into height. Half into base into height. But mind it, this area is negative because it is below. What is its top? Positive. Whatever is below is negative. Base. 40 to 50 is 10. Height is basically 10. So 10 tens are 100. So it will be minus 50. So hence the total displacement will be 300 minus 50, which is 250 meters. Which is 250 meters. Is that clear? Very good, Sachin JEE Warrior. Give the answer really quick. Awesome. Awesome. So, yes, so you should know this formula. Whenever you have trapezium, see, a lot of people, what they will do is they will split triangle, square, triangle. It's such a tedious task. Don't do that. This formula is direct. Area of a trapezium is the sum of the parallel sides multiplied by the height. So here you can see one of the side length, this one was 20, because 30 minus 10 is 20, this side. Okay, this is basically going to be 20, right? And this side was basically 40, and you multiplied with the height. Height was basically 10. So you got it as 300. Next thing, for this particular triangle, the base is basically 10. You can see 40 to 50 is basically 10 units. And the height is basically again 10 units. But it is negative because it is below the time axis. Areas above are counted positive, areas below are counted negative. So take that 300 and subtract it with 50, you will get the answer as 250, because displacement is the area. Whenever you have to find displacement, this displacement is always the area under velocity versus the time graph. Got it, everyone? Nandu, everyone got it now? Mesu, very nice. Moving on to the next question. The displacement time graph for two particles in a straight line inclined at 30 and 60 degree with time axis, the ratio of the velocity is. So what do they mean is, see, they have not given the graph, but this is displacement versus time graph. There are two graphs. One is at 30, one is at 60. So one is at 30 degrees, the other one is at 60 degrees. So 30 and 60. So for A and B, question is, what is the ratio of the velocities? See, when displacement time is given, velocity is nothing but the slope of position versus time. And slope is tan theta. Slope is nothing but tan theta. I have told you this over here also when I explained you the concept of slope. Slope is nothing but you draw a tangent and measure the angle. So tan of theta is nothing but the slope. That is what I have told you. Great. So over here also, the tangent is already a straight line. So just have to find VA by VB. VA for A, the angle made is 30, so it will be tan 30. For B, the angle made is 60, so it will be tan 60. Tan 30 is 1 by root 3. Tan 60 is root 3. So root 3 into root 3 is 3. So the answer will be 1:3. 1 is to 3. That means the answer will be option D. That means the answer will be option D. Correct. Sir, can value of ratio be negative value in any case? Yes, why not? It can be negative. Say for example, instead of one graph like this, one graph like this was 30, this was 60, something like that. Because one is going down, so it will be minus 60. So the answer will be minus 1 by 3. Okay, and the options will also be modified. Maybe some of the options are negative. So you can have those kind of things also. So a ratio can be negative also. No harm in it. No. Is that right? Okay. How about this? The graph of displacement time is given. This is a level 2 question if I'm not wrong. How will the velocity graph look like? From displacement, think logically, guys. If I draw tangents, what I get is basically velocity. So here you can see the slope is changing, right? I hope you can see that the slope is changing. I think eventually, the slope becomes flat. I mean, it becomes 0, and then it starts going down, interestingly. Right? Then it starts going down like this. You can see that right over here. Yeah, it goes down. It is going up to down. Here the slope is becoming negative. Here the slope was positive, and somewhere here in between the slope was 0. So whenever I'm looking at the slope, I'm looking at the velocity. Okay, so the slope over here in the first case, so the slope over here of displacement versus time is actually giving me velocity. That means the velocity was initially positive, then it became 0, and then it became negative. Is there any graph like that which has positive value, then 0, and then negative? Here, velocity is always positive value. So obviously C option is wrong. Here, velocity was negative, then 0, then positive, wrong. Negative, 0, positive, wrong. This seems to be correct. This seems to be correct. You can see the velocity has positive values before. You can see this part, the velocity is definitely positive. Then exactly at this point, it is 0. And then after that, it is becoming negative. It is going below the time. So I think the correct answer to this particular question should be option number A. Is that absolutely understood? Clear? Yep. Everyone? Yes, it is answer A. It is not C, Divakar. Awesome. Awesome. Moving on to the next question, guys, coming up on your screen, and here it is. The displacement of a point moving in a straight line is given by this. Calculate initial speed and speed at 4 seconds. Displacement is given, speed is asked, basically velocity. You have to take the derivative. So V is ds by dt, as simple as that. So just take the derivative of 4t square plus 5t minus 6. What is the derivative of 4t square? 4 is a constant, bring it outside. T square's derivative is 2 into t raised to 1 plus 5 is a constant. T's derivative is just 1. Constant's derivative is 0. So hence it will just become 8t plus 5. That is your velocity. The question is, find the velocity at two different places. Initial speed. So initial means put time as 0. So 8 multiplied by 0 plus 5. So the initial velocity will be 5 meters per second. So first part is done. Now let's go to the next part. Speed at 4 seconds. So speed at 4 seconds means put the value of time as 4 and add 5 to it. 8 4s are 32. 32 plus 5 is 37. So 37 meters per second is the velocity at 4 seconds. Done. 5 and 37. Very good, Divakar. Congratulations, guys. Slowly you guys are getting a hang of derivatives. How about this question? This is another high level question. Moving on to the next one, guys. Velocity changes as 4t. Calculate the displacement from 2 to 4. Calculate the displacement between 2 to 4. From velocity, if you have to go to displacement, you have to integrate it. That's the catch. So displacement delta x is integration of velocity with respect to time from t1 to t2. So from 2 to 4, that is what you have to find the displacement. So that is exactly what S is, from 2 to 4, from 2 to 4. So I will change the limits. This will be 2 seconds, this will be 4 seconds. Instead of velocity, I'll put it as 4t and then multiply it with dt. 4 is a constant, bring it outside. Times integration is t square by 2, t square by 2, and limits are 2 and 4. So displacement from 2 to 4 is, 4 is just a number. Put over here 4 square by 2 minus, then put 2 instead of time. So 2 square by 2. So what will happen? 4 and 2 cancels, it will just become 2. 4 square is 16, 2 square is basically 4. 16 minus 4 is 12, 12 to the 24. So 24 meters is the answer of the displacement. 24 meters. Exactly. We had to do integration. Moving on to the next question on your screen. Okay. Next question, very interesting question. X is t cube. Find position at 2 seconds. Find average velocity from 2 to 3. Find velocity at 2. Okay, straightforward. Position is given and they are asking you at 2 seconds. Just think about it. At t is equal to 2 seconds, what will be the position? Just put time as 2. So 2 cube. Therefore, position is basically 8 meters. So this is the first part, which was very, very straightforward. Now let's go to the next part. Average velocity and all of that is asked. If average velocity is asked, that means I have to find displacement and then divide by time. To find displacement, I need the positions. Okay. So I understand one thing. For average velocity, I need displacement and I need to divide it by time. Displacement is change in the position. So this position at 3 seconds minus position at 2 seconds upon the time interval, which is 3 seconds minus 2 seconds. What is x3? When you put time as 3 seconds, when you put time as 3 seconds, it will become 3 cube. X3, basically put time as 3, it will become 3 cube. X2, you put time as 2 seconds, so 2 cube. 3 minus 2 is 1. 3 cube is basically 27. 2 cube is basically 8. So this will just become, put it over here maybe, average velocity will just become 27 minus 8, which is nothing but 19 meters per second. That is the second part, which is B. Very good. So many of you have got it correct. Find the velocity at Find the velocity at 2 seconds. So instantaneous velocity is just the derivative with respect to time. So derivative of t cube with respect to time. So t cube's derivative is 3t square. But you have to find the velocity at 2 seconds. So v2 will be 3 into, instead of time, put it as 2. 2 square is 4. 4 into 3 is basically 12. So the velocity is 12 meters per second. This part also done. That's how you solve this. Okay, cool. Understood? Oh, clear? Oh, very good, very good. So now it's time for vertical motion under gravity, but this part we will do after the break. We will do it after the break. Now it's 7:45. We will meet at 8:05 p.m. We will continue. We'll continue after the break. Okay. So meanwhile, make sure you are liking the video, and if you have any comments, if you're watching it recorded, please comment it. Of course, please share it with your friends also. Okay, please share this particular video with your friends. Okay, I'll see you very soon. Where's the timer?
My dear warriors, I'm really sorry. I might not be able to continue this class right now um, because of only one major reason. Backache is not the issue. Even if backache was there, I will still continue. Main problem is I have to go on a news channel for an interview live right now. So I know if you're watching it recorded, it might sound very absurd, but yeah, I have to go on NDTV English live regarding the NEET controversy. So you can also watch it over there. Hopefully, you'll catch me over there live. If you have not yet subscribed to NDTV channel, just subscribe to it. On Tata Sky, it is 601. Not sure on other networks, cable operators, what is that going to be? Okay, so I'm so sorry. I'll have to end this class. The next part of it, which is free fall motion, only that part I will take it separately. Okay, is that fine? Done? Cool. So other things we have done properly. Okay. So I'm really sorry, but that is also important. So I cannot say no to them also. Right. Okay. See you guys. Bye bye. Take care.